Unit 2, the set of real numbers. When we have expressions, this includes variables as well as numbers. This is the basis of algebra. Finding an unknown and then putting a component in there to get a solution. The expression 6y, where y equals 7. Well, wherever we see the y, we put a 7. And since 6 and y are touching each other, that means they're multiplying together. 6y equals 6 times y. Replace the y with the 7. 6 times 7 equals 42. So in 6y equals 6y, where y equals 7, that equals 42. Fractions are the same way. 5y over z, when y is 15 and z equals 25. Where I see the y, replace it with the 15. Where I see the z, replace the 25. And since the 5 and the y are touching, and I replace the y with the 15, it's now 5 times 15 over 25. 5 times 15 is 75 over 25. And 75 over 25 is 3. Similarly, p plus q over 2, where p is 2 and q is 16. I replace the letters with the given numbers. The p is replaced with the 2. The q is replaced with the 16. And this is over 2. 2 plus 16 is 18 over 2. And 18 over 2 is 9. Another component is absolute values. When you see these two vertical lines surrounding a number or variable, this refers to an absolute value. There's no negatives in absolute value. I'll give an example. If you took 3 steps to the right, that would be plus 3. You took 3 steps to the left, that would be minus 3. However, regardless of what direction you went, you still took 3 steps absolutely. So given this, with these two vertical lines on each side, the absolute value of negative 6 is 6. The absolute value of 325 is 325. The absolute value of negative 3 5/8 is 3 5/8. Inverses. This is looking at the other side of the number line over that 0. In other words, if I have the number 64, I go over the 0, it becomes 64 for the inverse. Negative 27, the inverse of negative 27 is 27. The inverse of 24 is negative 24. And this is similar with variables. The inverse of x is negative x. The inverse of negative y is y. Adding, subtracting fractions. When we add, subtract fractions, remember we have to have the same denominator. We have 2 different denominators, we can't add them together. We can only add or subtract if we have the same denominator. I have 5/8 plus 1/4. These are 2 different denominators. One is 8 for the 5/8, one is 4 for the 1/4. The numerator is the top part of the fraction, the denominator is the bottom part of the fraction. How do I have common denominators? Well, I need to convert them into a common number. And I think I can convert that 4 into an 8. So that 1/4 can turn into 8s. Leave the 5/8 alone. If I multiply 1/4 times 2 over 2, that's the same as 1. Multiplying anything by 1 gives the same number. So I'm not changing anything. Just rewriting it so I can have a common denominator. So if we multiply 1/4 times 2 over 2, which is the same as multiplying times 1, got the same result, same number, except instead of 4ths, it's now an 8ths. 1 times 2 is 2. 4 times 2 is 8. So now I can add that 5/8 with 1/4. I rewrite it as 5/8 plus 2/8, which is the same as 1/4, and that's 7/8. Negative numbers. Remember, when you add a negative number, that's the same as subtracting a number. 4 plus negative 3 is the same as 4 minus 3. Negative 11 plus 5, which is the same as 5 plus negative 11, which is the same as 5 minus 11, which is negative 6. Similarly, when you multiply a negative number by a positive number, you get a negative result. 9 times negative 4 is negative 36. However, when you multiply a negative number by another negative number, you get a positive number. Negative 4 times negative 3 is positive 12, or simply 12. Like multiplication, when you have negative numbers when you're dividing, a negative number divided by a positive number is negative. Negative 24 divided by 8 is negative 3. If you divide a negative number by another negative number, its resulting is a positive. Negative 18 divided by 2 is 9. Now, the reciprocal, which we'll also be using in algebra, is the flipping of the fraction. So the numerator becomes the denominator, and the denominator becomes the numerator. 3/8, the reciprocal is 8/3. 5/9, let's flip it over, the reciprocal is 9/5. X over 8, the reciprocal is 8 over x. Even with variables, we just flip it over. 1/4, the reciprocal is 4 over 1, or 4. And a reciprocal of 9, which is the same as 9 over 1, is 1 over 9, or 1/9. The distributive property multiplication allows us to multiply things out in simpler formats. If I have 4 times that factor x plus 3, remember that 4 is touching those parentheses, so that means I'm multiplying it out. And when 4 times x plus 3 is 4 times x plus 4 times 3. I'm distributing. 4 times x is 4x, and 4 times 3 is 12. So 4 times x plus 3 is 4x plus 12. Similarly, 9 times the factor 6m plus 7, I'm multiplying 9 times 6 is 54, so 9 times 6m is 54m, and then 9 times 7 is 63. So when I multiply 9 times 6m plus 7, I distribute out, I get 54m plus 63. Factoring is the reverse of this. This is where it's bringing it down to its simplest components, and we put parentheses around it. I see the factor 30 plus 5y. And I look for something. What can I pull out of both of those to simplify it? I can pull out a 5 out of a 30. That goes in 36 times. And 5 goes into 5y one time. And we don't put 1y, we just put y. So 30 plus 5y can be factored as 5 times the factor amount of 6 plus y. And if I go back and check this, 5 times 6 is 30, 5 times 5 is 5y. Also, I want you to be careful. Removing parentheses. I've got 4y minus the factor 2y plus 5. I'm subtracting everything within those parentheses, not just the 2y, but everything within those parentheses, which is 2y plus 5. So if you write this is 4y minus 2y minus 5. That would equal 2y minus 5.